Alright nerds, so now we're going to talk about specific families or groups, chemical families or groups within the periodic table. So by the end of this you should be able to describe in a fairly simple form the properties of the alkali metals, the alkaline earth metals and the transition metals. So let's get into it. Now you need to remember that trends exist in the periodic table, and because of this, elements can be grouped together in chemical families. And this is all because of the trends that exist there. Alright, so group 1, or I, the alkali metals. Now, of course, it ignores hydrogen here, which is not a metal. It's over there, it's chilling, but that's just because it's got the positive valency, and it's got the, all metals have positive valencies, and it's only got the one electron in the one outer shell. That's why it's chilling there, but it's not a metal. So we're looking at lithium down to francium. Now, these are your group 1 metals. They all form +1 ions. Okay, so they have one electron in the outer shell, so it's really easy for them to lose it. This means they are all extremely reactive. They react very easily. Because of this, we don't find them in nature. They don't exist out there in its native form. Okay, and what that means, native form, that means that it doesn't exist as just lithium or just sodium. It's sodium chloride, it's lithium chloride, whatever, they'll join the chloride. It's the metal joined with something else in a compound. It's never just the metal sitting in the ground like you will with gold. They have typically metallic properties. They are very metal. And not just because they're explosive and have rad guitar solos. They're very metal. You know, they're hard with the exception of lithium and sodium. But as you remember, I said, we go further down, it gets even more metal. They're shiny and so forth. Like they are very metal. They have all those properties. They can be drawn into wires, and they all display similar chemical properties. Like if we join any of these with chlorine, it becomes KCl, NaCl. Like it's. Whereas if we put magnesium, it becomes MgCl2. So they all have fairly similar chemical properties. They all have low melting points. Some of them around 40 degrees. Now if we get into our group 2s, our alkaline earth metals, we move on to group 2, so we're talking about beryllium down to radium. Okay, this is a pretty group. This is a cool group as well. They form 2+ ions. Okay. It's easier for them to lose the two electrons in the outer shell than it is to gain 6. They're very reactive still, but they're not as reactive as group 1. Okay, like they just aren't. They have typically metallic properties again, like you can see here. They all look like metals. They all display fairly similar chemical properties. They have very high melting points. Not quite as high as some of the next ones we're going to look at, but high melting points. The next ones we're going to look at are the transition metals, and this is group 3 to 12. It's that weird little block you see in the center. Now, we'll pull up a picture of which ones they are in a minute. They all have similar properties, okay? They're hard. They have high melting points, high densities. They are less reactive than groups 1 and 2, and some of them are inert, and that's why gold, which is Au, and PT, which is platinum, are used in jewelry. They don't react with anything. They just stay cool. Some period 4 metals, 3 of them in fact, are magnetic, and that's nickel, cobalt, and iron. Iron is Fe. This is basically where we get all our... If you're looking at a dye, it's because of these metals. So these are the colourful ones. So if you get coloured glass, coloured anything probably, it's got a transition metal in it, and this is where we get all our wonderful colours from. Anytime you see fireworks, that's because in with the gunpowder, they'll put shavings of copper, and that gives you the blue, or shavings of strontium, and that gives you the red, and so forth. So all your colourful ones, they live in this transition metal section. And it's these ones here, okay? So it's that block in the middle that's between 1, 2, and 13. All right, so the highest melting point of any metallic element is tungsten at 3,400 something degrees. We've got 3 magnetic ones. Various oxidation states. You don't need to know what that means, but that means that they combine in all sorts of weird and cool ways. All of the ones that we've made coins out of essentially come from this group here, including, so this one here says silver, gold, copper, but you've also got nickel in there and zinc and so forth. It's got the only one which is so even though they've all got generally high melting points, you've got mercury in there. Don't need to worry about that. It's all the pretty colours. These are the colours you get out of it. And yeah, so transition metals are pretty cool. So we hope you got all those properties down. We'll play with some of them in class. And then the next lesson we'll move into the right-hand side of the periodic table. See you in class.